Hello! In this video, we're going to look at how to use arguments and parameters when you're writing functions. Let's do an example where we're going to write a function that calculates how long it will take an object to reach the ground if we drop it from a given height. So this is your basic freefall equation. So let's call our function freefall, and we want height to be a parameter that we enter into the function when we call it. So the formula for that is that the time equals the square root of 2 times the height divided by gravity. And we want the function to print time. Now I'm getting a couple errors here because I need to import math. And I need to define gravity. Okay. Let's go ahead and actually also round the time. Alright, so now I'm going to call my function. When I call it, I need to enter the argument 10. So let's run it. And I get 1.43, and that would be in seconds. Okay, so height here is, again, what we call the parameter. And the parameter is a variable that is part of a function that will receive an argument. And the argument is 10. So everywhere that height shows up in our function, 10 gets replaced with that when the function actually runs. Let's expand this example to add some more parameters into the equation. So let's say that we don't just drop it from a height, but we also throw it straight up or down, so it'll have an initial speed. And let's say we want to have gravity be a parameter in case we are not close to the surface of the Earth, or if we're on another planet or something, and we want to simulate that. So we'll need to expand my time equation. And the formula for that is what you see here. And it's actually a quadratic formula, so there could be 2 times that are given. So let's go ahead and call this time 1. And the formula for that is going to be negative speed minus the square root of speed squared minus 4 times the term that would be on the t squared of the formula, which is gravity divided by 2, times the starting height. And that whole thing needs to be divided by gravity. Okay. So that would be one of the formulas here. That would be the positive formula. Since it's quadratic, we would want to go ahead and calculate that value if we have a minus sign here between the speed and the square root. Okay. Now, obviously there can't be 2 times, like we're not calculating a bounce or anything. We just want the first time the object hits the ground. And that should be whichever time is longer in our equation. So let's write some conditional statements so that we only get one value out. So if time 1 is longer, we want to print time 1. If time 2 is longer, we want to print time 2. And this should be elif. And then there is, an edge case where the times could be equal, and in that case, we'll just print time 1. So there could be some other things going on here. There might be some edge cases we missed, but for this kind of simple example, let's call it good enough. Now, we do need gravity to be negative in these, since gravity is always going to be towards the center of a planet. And we don't have a way for to check right now if what the user enters here is negative. So let's write a conditional for that too. So if the gravity value is positive, we want to change it to be negative. Okay. So let's go ahead and call this function, and let's use the same numbers as we did before as a check to see if it works. So we'll do height 10, speed 0, gravity of 9.81. Okay, we got the same thing. So now we can enter some different numbers. Let's say we throw it up at 10 meters per second. Let's say we're a kilometer up, 1,000 meters, and let's say we're on the moon, so gravity is like 1.6 something. All right, in that case, it would take 42 seconds to come back to the ground. So here we had 3 parameters and 3 arguments that got passed to each of those parameters every time they were called. So every time gravity showed up here, it took this 1.6 number from the argument that we put in for gravity. So that's a little bit about how you use arguments and parameters in functions, and this can help make your functions more flexible, and it helps you reuse your functions so you don't have to hard code numbers directly into them. Something else we can do is define default values for these parameters. So when you're defining your function, we could say that the default value for height is 0, the default speed is 0, and the default gravity is 9.81. Let's say we want to assume that we're on Earth. Then I don't have to enter all of these when I call the function. So let's say I just put 1010. So 1000 for height, 10 for speed. It still works because my function has a default value to fill in for gravity, even though I didn't provide one. Now with default values, you can also do things like directly call the name of the parameter. So I could say that I want my height to be 500, I want my gravity to be 50. So there, even though I didn't give it a speed, it still works. And it knew that I wanted the first entry here to be height and the second one to be gravity because I used the names of the parameters when I was defining the arguments. So there are multiple ways you can call these things, and there are multiple ways to use arguments and parameters. So I invite you to explore those a little bit and use them to make your function writing a little bit more flexible.